Okay, so let's take a look at an example here. So this one isn't so bad. So it's just a matter of kind of picking out what the pieces are, right? So when I say the amount is 500 bucks, that's the initial. That's what's going in first, okay? And it's deposited into an account that pays 9.5%. So that's the rate. And as a number, that's 0.095, right? Okay, so that's kind of important to do. And then it says it's going to get compounded monthly. Okay, so this little piece here, this R divided by N, what's 0.095 divided by 12? Can somebody do that for me? Because I'm kind of slow. I don't have a calculator anywhere here.
It's 0.0079.
Okay, so 0.095 divided by 12 is equal to what again?
0.0079.
79? Okay, good enough. Okay, so all this means if it's compounding monthly for me, okay, that means that every month after January, my $500 is going to get this little hit, right? And so after February, I'm going to get, two of these. Okay, it's going to this rate is going to hit my 500 bucks again, but it's going to be 500 plus whatever the first one was. So it's going to be a little bit better than if it was just compounded annually, right? I'm getting those little jumps at every step. Okay, and how many years did they say here? 3. All right. So when we go and set this whole thing up, I think a better description might be to compare the two in the calculator. Okay. So anyway, let's do this. So A of t is going to equal my 500 times 1 plus, and I would do this in the calculator just like this. I wouldn't like do anything out in front. I would do it in one big fat. So how many times is it going to get compounded? How many years? Times the 12, right? 3 years, 12 times per year, right? Okay, so let's just find what that is. I want to put it in the calculator instead. Okay, let's do this as a function instead of just as one question. Let's kind of have if every question was in there. And then I want to compare it to if it was just compounded annually. Okay, so let's put 500 times, and here that's kind of nice to use your calculator like this too. You've got this little fraction option that I would use, divided by the 12 times, and then I'm going to put up here 12, oops, sorry, should be an exponent, 12 times x. Okay, so I don't see anything, kind of like you would expect, because I'm starting with 500 bucks. So let's go and look at the table and kind of get a sense. We want it for how many? 3 years, right? Okay, so look at, this is how big it's going to be after 3 years. So I started at 500. After the first year, it was 549. Okay, 9%. That's something seems a little weird there. No, it doesn't. Good. I would expect kind of like 10%, right? So 50 bucks, right? The next year, kind of another 50 bucks, but a little bit more. Next year at 664. Okay. Let's take a look at what it would be like after 20 years. Your 500 bucks would already be at 3,318. Okay, so you can kind of see the exponential part of it as the time gets bigger. After 30 years, you're already up to 8 grand. 40 years, up to 22,000 now, right? Because you keep doubling basically every how many years? If it's 9.5, about how many years is it going to double after? What's the magic number? 70, right? So it's going to be about every 7 years and 2 months or something like that, right? Okay, is how it's going to double. Okay, so you can just get this answer straight off the table though when it was to 3. Okay, so 664th 14. Okay, what would the equation look like? Okay, if it was just your compounded yearly, what would be the difference between the two formulas?
The 500 times 1 plus 0.095 over 1.
Yeah, sure. You could put 1 here. You could just leave it blank, right? You could just do this.
And just
How significant is that difference going to be when I look at the two graphs? Like if I overlay this graph, let's find the picture here. Okay, so we wanted this to be at around. Let's make this go 10 years. Sure, let's make it go 20 just for fun. Okay, and we kind of started at, we were going up to like 600 after 3. Let's give it 20,000. And here, let's make it minus, I don't know, 5,000. And actually, let's take this up to 30. Okay, so let's see what kind of picture that gives us. It's not bad. Okay, how much different, what my question is how much different is it going to look between compounded monthly and compounded yearly? Is it going to be a significant difference? Am I going to see two lines that are kind of the same there? What? I need a guess. Yeah. So first of all, if I do this yearly one, is that graph going to be above or below the monthly one when I compound monthly? The yearly is going to be above? Below, right? Because here I'm getting paid interest more times throughout the year. It's still going to be 9.5%. It's just that I'm getting interest on interest more often. Every month I'm getting interest on interest here, right? Okay. Whereas here I'm just getting it once. I'm getting interest on one principal payment after 1 year. Okay. So I should expect it below, but I want to know, like, is it going to make, after 2 years, is it going to make like a $10 difference, a $100 difference? What? Big or small? No one wants to take, let's take a look. No one want, you think big? Let's see. Let's go 500 times 1 plus 0.095 all to the x, right? Is it going to be on the same screen? Let's try it like that.
No.
You don't think so? Let's try. I'm going to push enter. Let's see what happens. It's almost identical off the beginning, right? Like we're a little below, okay? This is 30 years, right? So the only time that we kind of see like a significant difference is when we get out to 30, right? That's when that little chunk of compounding interest is going to make a difference. Like if I go to my table, I should be able to see both. You can kind of see the differences here, right? After the first year, it only made like it was $2. Okay? Second year, kind of the same, right? It looks like it was about $6. You know what I mean? Okay? But it's always going to be a little bit under because here I'm making interest on interest every payment that they give me. Okay? Is that kind of a good way to say it? The only time that this is going to actually make a significant difference is if I put this out to like 50 years. Here, let's do it. Let's put trace and put like 100 years in. 1 year. Let's try it at 100. See what happens. Okay, so at 100 for this graph, I've got this huge number. Are we in the millions yet? Yeah, like about $6 million. Okay, my 500 turned into, at 9% interest, turned into 6 million. after 100 years. And the yellow line, yes, 6.5 million more or less, right? The yellow line is only at 4.3 million. So over 100 years, the same interest rate, just getting compounded monthly, is worth about $2.2 million over 100 years. Okay? But that 500 just sits in there. So if you had $500 and you wanted to make a nice little retirement package for yourself, just leave it in there for the rest of your life and make sure you get 10% interest on it. You'll have $6 million at the end. All right? Okay? That's it. That's all I got to say about that.